Today we are going to present, as you did, our intern project. We are Luis Fernando and Juan Pablo.
The internet. Who doesn't love the internet? Well, I guess we can all agree that the internet nowadays has become a great part of our lives. We use it every day and for a lot of things. But if we are constantly using the internet, can any one of you tell me one of the features that appears in most web platforms that you can find almost anywhere? Please give a guess. You as well. Search through the YouTube interface and see if you can see what that feature is.
Search.
Search, that's a good one. That's another one. Who else?
Image.
I guess that could work.
Classification.
A lot of things. But one of the most important ones, accounts. In almost every single web page that you find, you can always create an account. What for? Well, to customize your experience, of course. You can access your account and get information stored directly for you, and to make the experience in that web page the best it can be for you and the web page itself. But there should be millions of accounts everywhere if it's a world wide web. So you can guess that finding an exact account and its information could be difficult. That's why me and my teammate have found a way to, I can speak, do just that. Let's begin.
Well, as JP said, technology is everywhere. We use technology for YouTube, as he mentioned, for learning, for, I don't know, using Excel, Word, I don't know, social media. We use technology for everything. It has unlimited uses. And well, all that generates information that needs to be obtained and needs to be classified, needs to be searched, and for it to be on their processes analyzed. And well, we are focusing on data handling. We give the problem owner the benefit of having this data sorted, having it all collected in one place, having it all with no duplicates if he wants. We can give him many different scenarios for him to analyze the information. So our computational problem is searching, managing, and accessing data in a database, identifying if the database contains a specific value inside it, as JP mentioned before.
Well, if we want to solve this issue, we have to apply data structures, which let us use our data in a more organized manner. But there's a lot of them. Right here we can see 4. So how about we use some of their characteristics to analyze them and define what could work best? Let's do the analysis first. First, we have the array. The array, well, as it says here, it's a line of, hold on, this was getting to me. Well, it's a line of memory blocks which go one after the other and is set to a fixed size in memory. To access each of these memory blocks, you have to use an index, which tells the pointer at the very start of the array where it has to go next. This allows it to get a very quick response time when searching for an exact element in the list, because, well, you just have to say in what index the element is, and it will go straight to it. Then we have the vector, the little brother of the array. The only difference that it has, and its main selling point, is that in comparison to the array, the vector can change in size because it's on dynamic memory. A very important concept if you're going to study this. This allows us for a little bit more free usage of the, well, data structure. You have broken your chains of being restricted to a certain size, and you can do much more, like keep adding values to to a database. Then, well, we have the linked list. This is a little bit more tricky than the last ones. This one is created by a bunch of nodes. Each node has a little value in it and a pointer, which tells you where the next node is on the list. This can be useful in some cases. This can be, well, disadvantage in others. Like when you go searching for a value in a linked list, you can't go directly to the value like in arrays and vectors. You have to go through every single node behind it to be able to reach that value because of the way it is structured. Then, of course, we have stacks, a very popular one this night. Well, stacks can be made with this, but work in a very exact way. All the values that enter the stack are put at the bottom, and the new ones always come on top. And the only way to access a value is if it's at the top. So you either have to take away the values at the top, or you can add the values at the top as well, but never at the bottom. Remember, the top.
Well, why we use vectors? Because we are using vectors because, as we mentioned many times before, we are searching. We are. Can you turn one back, please?
Yes. I'll be the last one too. There we go.
Well, yeah, we are searching, we're accessing, and we are adding more values to the list. And the best solution for it was a vector, as it does everything very efficient. And also because others like other similar last linked lists, as JP said, you need to pass to every single part of the list to access the value.
Well, for that solution, it's quite simple. Let's pick it on paper before we go to the code itself running. So what we do is we first ask the user to tell us what element they want from the list, the database. Because the main objective right now is we need to find that user in the cloud of profiles that exist. So we first get the user we're looking for, and then we go to a for loop. This for loop, what it does is that it has an iterator that slowly but surely raises in value. We use this iterator as an index to search through the vector. In each and every single iteration, we pass through an if statement that tells us if the value stored in the username member of that profile is the same as the one we're looking for. If it is, the value of the index is returned. If it's not, it does not do anything at all. So the cycle continues, and if the value is not anywhere in the list, it will just return you a -1. So if we want the value and we want to access information in that exact profile, we just go there by getting the index from this function. But if there's none, well, it's going to be -1. And since there can't be an index of -1, we can just tell that it's free and we can use it if you're wanting to make a new profile with that. There's a bunch of other methods that we use for our solution. Some of these are more cosmetic. Well, I guess we can already pass to the code. It should be right about here. So let's get this baby off and running. First, we're met with our menu just to get a little bit more variety. We try logging in. Well, there's no accounts. So we have to go back and make a new one. Let's call ourselves Edgar. And let's put the password as what? Siniestro. How we find it? All right, we created a new profile, and that's now stored in the database. So let's just create another one, just so that we actually have to search for it. There we go. Now Well, we'll if we had time.